Okay, good friends. I'd like to talk to you today without mathematics about something that really is in the language of mathematics. Einstein's Annus Mirabilis, his miraculous year in which he wrote 4 separate essays, each of which deserved the Nobel Prize. And indeed, he won the Nobel Prize for one of them. He wrote them in 1905 as a 24-year-old person, and the fourth of them you actually know the conclusion of. E equals mc squared. At the time, that was just a wonderful theoretical idea. Now it's a reality. What exactly he did in the others starts with an essay in which he realizes that light, though every form of light travels in a vacuum at the same speed, c, that astonishingly large quantity, 300 meters per second, a little bit less, but that's close enough. He realized that though it all travels at the same speed, some of it has greater force behind it. Quantum, he called it. And if you shoot that light off an iron plate of some kind, it doesn't matter what kind, the strongest of those forces will bounce electrons off that plate. The others will not. And so he said, quantum exists. It was in fact a practical recognition of the validity of Max Planck's special number that he created simply to make his calculations easier. It turns out, indeed, they made the calculations easier because they were, in fact, a reality. Einstein had actually come up with that insight for his PhD dissertation. And he presented that to his professors as a reason to recommend him for a professorship. They refused. And in fact, one of them told him, "It's nothing, you found one little piece of information that has no other application." Well, it turns out that that's the beginning of quantum theory. That's the beginning of the recognition that events happen in relation to probabilities, not in relation to exact numbers. Einstein, by the way, though he creates quantum, doesn't agree with that. He thinks the mathematics has to be exact. His mathematics is exact. In any case, that's the first of the pieces. The second one is about what happens in Brownian motion. You have a liquid that somehow or other, little particles within it move at an absolutely random form as a result of what? Einstein figures out, he's 24 years old, Einstein figures out that in fact they move at that apparently random method because they're being hit by little objects within the liquid. those little objects are atoms and molecules. That, in 1905, was the first proof that there actually are atoms and molecules. Oh my goodness. And then he did what perhaps is the most famous of the four things. No, the A equals MC squared is the most famous, but what led to the EM equals MC squared, he did an experiment to try to determine why it is that light moves at its own speed irrespective of the movement of what it's coming off. If I throw a ball as I'm on a train, and I throw the ball forward and the train is moving forward, the speed of the ball for someone sitting at the tracks will be the speed that I threw it at, plus the speed of the train. Or if the train is going the other direction, the speed of the ball will be the speed of the ball minus the speed of the train. Light travels at its own speed, no matter what the train is doing. So, they tried to come up with an answer to this before Einstein came along, and the answer that they came up with is that light doesn't really move through the atmosphere. It moves through a special kind of atmosphere of its own, which moves in the opposite direction of whatever is moving. So they said the light is moving at its speed plus the speed of the train, but it's not moving through the atmosphere, it's moving through this luminiferous ether, and the ether backs it up, going in the opposite direction of whatever the light is shot off. Everyone accepted that idea except Einstein, 24 years old. And he says, if you have the proof of something that has no other evidence of its existence except that it proves that one thing, throw it out. It's not real. And he realizes that light moves through a vacuum at the speed of time. As a result, the speed of light and the speed of time are equal. Whoa. Zero is the result. And he has a little conceptual experiment to demonstrate that, which actually he thought of as a teenager, and that was that if you sat on a light beam moving away from a clock, you would have the same speed for yourself as you move away from the clock. 3 o'clock, when you start to move away on the light beam, it'll stay 3 o'clock because you're on that light beam. My goodness gracious. Ultimately, he realizes that there are consequences for that in terms of the mass of something that's moving along, and that recognition leads to E equals MC squared. An astonishing set of miraculous insights by this 24-year-old genius named Einstein. Thank you so much for being with me today. I'll talk to you next time.